Welcome to Rosmaya Mohtar YouTube channel. So today we will enter chapter 2. So the topic for today is capacitors. Okay, the main topic. So we continue from that day. We have discussed about dielectric. Dielectric. So we continue a little bit on dielectric. Okay, so we are going to discuss the dielectric when it is inserted into situation. Okay, so consider these two situations. Okay, what happened to the capacitance of the capacitor? Okay, capacitance is the measurement for the ability of the capacitor to store charge. So the first situation here, okay, refer to the diagram here. So the battery is attached to the plate, okay, of the capacitor. To the capacitor lah is attached. And another situation, no battery is attached here. Okay, then the dielectric is inserted. Okay, the dielectric is inserted. So what happened to the capacitance? Okay, so this is another diagram to show what is the situation is. So the first one, this is the capacitor attached to the battery. Then finally, the final situation, the dielectric is inserted. Okay, the second one, initially the battery, the capacitor is charged, right? Okay, is charged, fully charged. Then no battery is attached. Okay, we take out the battery. Okay, take out the battery, is unattached. Then we insert the dielectric. Okay, can see the two situation or not? Okay, the difference between the two situation. Okay, so for the first situation, okay, what happened? Okay, so we go to the first situation. This is the second situation. Second situation. So initially charged. Okay, initially charged, fully charged. Okay, then we take out the battery. Okay, take out the battery. Then we insert the dielectric. Okay, we insert the dielectric. Okay, this is the plate, the capacitor. Okay, the capacitor has electric field E. Okay, the capacitor has electric field E. Okay, then we insert the dielectric. Okay, so what happened? This one we discussed before. So what happened? Because of the polarization, okay, the molecules arrange themselves here. Negative side is attract to the positive. Okay, we move to the positive, and the positive side of the molecules will turn towards the negative plate. So the resultant of the electric field here decrease. Okay, the electric field decrease. Okay, from E equals to V per D, if the E decreases, V also decreases. Okay, because the D is distance between the plate remain constant. So when E decreases, the V decreases. Okay, this is what we discussed before. Okay, we continue in today's lesson. Okay, then continue with the Q equals to CV. Okay, Q is charge stored in the capacitor. Okay, where initially we charge it. We charge with the battery attached. Now we take out already. So the Q here remain constant. Okay. So when the V decrease, Q remain constant because the charge in the capacitor cannot run anywhere. Okay, it remain in the capacitor. Okay, the capacitor is a metal plate. So Q is constant, but the C change because of the V change. So how they change? So when the V decrease, C also decreases. C increases. When the V decreases, C increases. Okay, can see from this relationship. Q equals to CV. So Q constant, V decreases, C increases. Okay, understand or not? Can you can write message there for me to know whether you understand or not. Okay, I can read from your message. Okay, now we go to the next. So when Q constant, V decreases, C decreases. Okay, now we go to the other situation where we didn't unattach the battery. Okay, unattach the battery. Sorry, we didn't unattach the battery. Okay, the battery here remain in the circuit. Okay, so this is the initial. Then we insert the dielectric. Okay, where the batteries still attached. Okay, attached to this capacitor. Okay, so initially, okay, what happened because of the polarization occur here? So the E resultant here decreases. When the E resultant decreases, what happened? The voltage decreases, but the voltage here is the voltage across the plate. Okay, the capacitor. Okay, so we call this VC. We have two V now, voltage from the battery, potential difference from the battery, and potential difference across the capacitor. So potential difference across the capacitor is decreases. Okay. So what happened? The Q increases because the supply here, the battery here supply more charge. So the charge will continue flows so that because the V decreases, the V across C decreases. So now the voltage not is unbalanced. If the voltage unbalanced, what happened? The more electron flow. Okay, more electron flow. Electron flow this way lah. So more electron flow because the unbalanced potential difference. Same as water. How they flow? So the water flow because different pressure in two places. Okay. For the current, different potential, they have different V, voltage or different potential difference. So that's why more charge flow. So what happened? The Q increases, the charge in the capacitor here increases. More charge flow. Okay, understand or not? Can Okay, so when the Q increases, okay, so how it will increases until the potential difference across the capacitor is same as the potential difference from the voltage. Then the charge stop to flow. Okay, the charge stop to flow when they are equals in potential difference. Okay, in another word, the voltage across the capacitor is made constant because the charge flow so that the voltage across the capacitor same as the voltage across from the source here, the battery. Okay, so we say that V constant. So when Q increases, V constant, the capacitance increases. So for both cases, okay, the capacitance increases. Okay, for both cases, capacitance increases. But for the first situation just now, okay, Q constant. For the second situation, V constants. Okay. So any question? Any question? Understand or not? Okay, okay. So I repeat again the conclusion that we have discussed just now. Okay, for the first situation, without a battery attached to the capacitor, and then we insert the dielectric, the Q constant because it cannot run away anywhere. It remain at the capacitor. So what happened is the V decreases, okay, and C increases. For this situation where the battery attached is not removed, okay, from the capacitor while we put the dielectric, okay, insert the dielectric. So what happened? The charge still can flow, okay. The charge still can flow because the voltage just now decreases across the capacitor decreases. So more charge still can flow because there's a source here from the battery. So that means the charge increases. So but the V remain the same. The V remain the same, constant. So therefore, when the charge increases, the capacitance also increases. So for both cases, no matter we attach the battery or not attach the battery, when we insert the dielectric, okay, the capacitance still increases. Okay, the capacitance still increases. Okay, this is the first part of our discussion today. Okay, so we try this example. Okay, we try this example. Okay, we read together the question. A parallel plate capacitor of cross-sectional area A is connected across a battery of potential difference V. A dielectric is then inserted into the capacitor. If the relative permittivity of the dielectric is 2.5 and the distance of separation between the plates is 0.050 millimeter, calculate the ratio of charge on the capacitor without the dielectric to the charge on the capacitor with dielectric. Okay. So what is the situation today? When the dielectric is inserted, with the battery removed or stay. Okay. So read carefully. I repeat the question. A parallel plate capacitor across the sectional area A is connected across a battery. So a dielectric is then inserted into the capacitor. So in this case, that means the dielectric is inserted while the battery is still attached to the capacitor. Okay. So that means this is which one situation? Is the situation where the battery is still attached. Okay, to get the idea, okay, I draw the diagram, right? Okay, so the battery is still attached when we insert the dielectric. Okay, this is situation before the dielectric is inserted. So for the initial with no dielectric, let's say the charge is Q1, okay, and C is C1, capacitance is C1. So this is V, the battery of the voltage of the capacitor is equals to the battery from the voltage. The voltage from the battery. Okay. So the voltage across the capacitor here, when it is fully charged, okay, is equals to the voltage across the battery. I repeat, the voltage across the capacitor here is equals to the voltage across the battery. Okay, then the current stop to flow lah. The current stop to flow. Okay, so we can substitute the capacitor capacitance here as epsilon naught A per D. Okay, this one we derived already. This equation, the relationship between C equals to the epsilon naught, because here air. So we if nothing here, this is air. So air we use epsilon naught. Okay, epsilon naught A per D times V. Okay, this is before the dielectric is inserted. Okay, next is the case where we insert the dielectric with the battery still attached to the capacitor. Okay, this is the second situation. I repeat again, with the battery still attached to the capacitor, so we insert the dielectric. Okay, what happened now? Which one is constant? Can you remember what we have discussed in the previous slide? Which one is constant? Anyone can write in the message there. Charge constant or voltage constant? Okay, good. Voltage constant. Min Sheng said. Ramesh also voltage constant. Okay, very good. So in this case, voltage constant, because the charge still can flow in the circuit supplied by the battery here. So what happened here is Q increases. So it's no longer Q1 but Q2. Okay, Q2, and capacitance also new capacitance C2. V remain the same, so we use same symbol V. Okay, we use same symbol V. Okay. So now we substitute the C. The C now is no longer epsilon naught, but we use epsilon naught, epsilon R, because we insert dielectric. D remain the same. We didn't change the distance between the plate of the capacitor. Area also, we didn't change the capacitor, the plate of the capacitor. So area remain the same symbol used. So the epsilon naught, the permittivity of the free space time the permittivity of the dielectric here for the when the dielectric is inserted. So we have two equations. Equation 1, equation 2. Okay, next, how to solve? The question asks the ratio of charge on the capacitor. So ratio of charge of the capacitor, which one is on top? Okay, we read. Ratio of charge on capacitor without dielectric to charge on the capacitor with dielectric. So that means Q1 per Q2. So we are going to calculate Q1 per Q2. Okay, so now we take the ratio Q1 per Q2. Okay, that means epsilon naught A per D times V per epsilon naught epsilon R A per D times V. Okay, this is the physics concept, and this is after this is the maths lah. We use ratio method, okay, to solve this simultaneous equation. Okay, now we can cancel out epsilon naught, and then we can cancel out area and cancel out D, V. Okay, so the equation become 1 per epsilon R, and epsilon R is given 2.5. Okay, so we can get the answer. So the answer is 0.5. Okay, so this example given is when the dielectric is inserted while the battery is still attached.